I'm just beginning, and there's a long way to go. To Amsterdam Central, and let me just search the shortest way to get there. Devices use GPS for navigation. But how does GPS work?
Hey everyone! Global Positioning System or GPS uses a network of satellites that are orbiting the Earth. The moment you turn your GPS on, the receiver gets the signal from these satellites about their current time and position. The receiver then calculates its distance from the satellite based on the time taken by the signal to reach you. There is some interesting math behind it. Consider a satellite A. Every point that lies at a distance x from A lies on this circle. Similarly, when a device knows its distance from a satellite, it knows that it has to be somewhere on that circle. When it receives signal from another satellite, it knows it has to be on the intersection of the two circles. But which one? So it takes the help of the third one to find its exact location. This is called Trilateration. Only in real life these circles become spheres and the device takes the signal from even more satellites for better accuracy. These satellites were launched and positioned in such a way that at least 6 of them always lie within the line of sight from almost anywhere on Earth's surface.
This system of satellites is called Global Navigation Satellite System. GPS, which was actually developed for military purposes, is the GNSS of USA. The other global satnavs in function are GLONASS of Russia and Galileo of European Union. Further, China, India and Japan also have regional navigation satellite systems.
But how many satellites in total are revolving around us right now? 560. And at Stuff.Space, you can visualize them and other space junk in a beautiful demonstration. But no matter how beautiful it is dangerous. Space junk is a collective name of all the disused satellites and other man-made debris that are orbiting the Earth. It consists of everything from entire spin rocket stages to explosion fragments, paint flakes, and dust from the rocket motors. And they are of various sizes, and there are about hundreds of thousands of them. And they can travel up to a speed of 8 kilometers per second. Even a small thing moving at this velocity is lethal for the functional satellites. For example, if an ordinary tennis ball revolving around Earth bumps into a satellite, the collision will release an energy equivalent to the explosion of 25 tons of TNT, and the odds of such a mishap are increasing every second. Whenever two pieces of space junk collide, they break up into smaller fragments, exponentially increasing the space junk and causing a cascade of collisions. And this is what is called the Kessler Syndrome. And it can be a bit of a trouble for further space exploration. This is an image of the Hubble WFPC-2 camera after its 15-year stay in the orbit, hit by several pieces of debris over time, as a result of the Kessler Syndrome. But it's not much of a problem for the GPS because the space junk lies about 2,000 kilometers from the Earth's surface, whereas the GPS satellites reside about 20,000 kilometers away. And these GPS satellites return to the same relative position over Earth twice a day. But why same relative position? Why not same position? This is because we're all moving. While the satellites are revolving around the Earth is rotating about 1600 kilometers an hour. At this speed, you can cover the journey between California and Amsterdam in 5.5 hours. Also, the Earth is revolving around the Sun at about 100,000 kilometers an hour. And at this speed, you can cover the journey in only 5 minutes. But our Sun is moving towards the star Vega and at the same time revolving around Milky Way at around 800,000 kilometers per hour. And our Milky Way in turn is moving through space at about 2.1 million kilometers an hour. If you ever achieve that speed, you can reach the distance from Amsterdam to California in only 15 seconds. Since the time you've been watching this video, we have already moved hundreds of thousands of kilometers in space. So technically, we can never be in the same absolute position in space in our lives ever again. Therefore, no matter how stuck you are in life, you're always moving. And thank you for watching.